So I thought of an idea in two people. So how can two people, well, yes, two people could be in a relationship, and no, we're talking like variables with numbers. So maybe it's okay. So, but yes, Pierce.
Hairs on the head.
Yes, and what could that be related to? So, when someone has hair on their head versus someone who doesn't have hair on their head, what's the difference between those two situations?
One person has long hair.
Okay, and what's the variable that affects that? Age. Age. Age is the other variable. We have the amount of hair on someone's head and age. As age rises, in a lot of situations, particularly with men, the amount of hair on their head declines. Okay? So I probably will lose all my hair one day.
My brother was 30.
These are the, oh really?
Mr. Schwartz, you have big heads of hair.
So I thought of a business situation in which there's a relationship. So let's think about in the late 1800s in the United States, there was a lot of immigration from Europe into the United States. They came into Ellis Island as immigrants. What could be a variable that could relate to immigration? One thing, yep.
Number of immigrants for Ellis Island.
Yeah, well, think about it. How about making that more general? Let's think population. Total population versus number of immigrants. Those have a relationship because they affect each other. Also, maybe something that might affect your parents. The people who work construction, when we have a rising population with a rising immigrants, then construction has more business because they need to build more homes and build more places to work for the immigrants. So now, looking at that, when two variables have a relationship, there's also a pattern that goes along with it. There's linear and nonlinear. Who's heard of linear before? Linear? We've heard of linear. What does linear mean? What's linear? Pierce.
Line.
A line. And Hunter, why is it a line? Do you know why? No, okay, so we'll talk about that. Yes?
Because they grow at an even rate. The numbers grow at an even rate. So they're make a line, straight line.
Yes, exactly. The numbers grow at a consistent rate with each other, so there's a straight line. So, here are two examples of pictures of linear relationships. So, think about that. We have two variables. Let's take it in line. We have two variables. There's a relationship between the two variables, and it has a pattern, and that pattern is linear. There's also a nonlinear pattern. So let's think of a linear first. For a linear pattern, I thought about for something that we deal with in text messaging. When text messaging first came out, there wasn't unlimited text messaging plans. It was you had to pay $0.25 or something for every single text message you sent. And yeah, how about that? And so when you pay $0.25 for each text message you send, is that a linear relationship? We send one text message, we pay $0.25. We send two text messages, we pay $0.25. It goes up consistently. It's a straight line. It's going to be, we have our text messages on the x-axis. That's the independent variable. I control that. I control how many text messages I send. And then the amount of money is the result. It depends on the text messages. It's going to be a straight line going up. And then we have nonlinear relationships. And those are relationships where you see a curve. Now, in our pumpkin project, what was the nonlinear relationship that we saw? Yes,
The
ma'am.
number of seeds
The number of seeds won, that was the one where it was dots all over the place. It was inconsistent. That was the one, there wasn't a, you know,
Diameter and circumference.
exactly. Diameter and circumference, because in the equation we have the exponent. Therefore, we saw the curve in our graph. That resulted in an exponential relationship. It's okay.
I forgot to lower it.
Anyway, an example that I thought of an exponential relationship is, let's think of snowfall. So, let's think of snowfall versus school days. When we have no snow, we always say we have school, there's no snow days. When we have 1 inch of snow, do we have any days off of school? No, we don't have any days off of school because we have good plowing systems and the roads are usually clear. 2 inches of snow, do we get any days off of school? No. Very rarely. 3 inches. No. 4 inches, you think? If we get 4 inches of snow, that's pushing it. What about 5 inches of snow now? That's a day off of school. That's 1 day off. They clear the roads that day, and then we're here the next day. We go up sometimes. What about 6 inches?
Even better.
Okay. Now let's think. As we go up inch by inch, if we're getting up to 8 inches, and we're getting up to 9 inches and 10 inches, that's a lot of days off school. So that almost takes off because we start at 0 and 0. And then 1 inch, we have a little. And so let's draw this. So we start off at 0 and 0. And 1 inch, we have a little. 2 inches, a little. 3 inches, a little. 4 inches, we're going up and up. By the time we get to a foot, we're having a ton of days off school. That's an exponential relationship. It is not a linear relationship. Okay?
Oh, yes.
Any questions at all about
I'm in
this?
class, I'm teaching.
Well, that would be epic. So, let's remember, just as a quick review,
Okay.
we have 2 variables. They have a relationship because they affect each other. When they have that relationship, it's either a linear relationship or a non-linear relationship. Linear means it's consistent, it's a straight line. Non-linear, it's exponential, there's a curve, it's not consistent. So, let's continue working on investigation 1.2. Thank you for listening so well. And then I'm going to collect those when the bell rings. And no, I'm not going to.